Hello, this video is designed to talk about how to describe data in statistics classes. For this video, it's just one set of data. Later on, you'll be comparing data sets. In both cases, you'll be using the same idea, which I call the big three. Other teachers will use CUSBS a lot. Sometimes you'll see their acronym SUCS. They all mean the same thing. Basically, you'll see in all these, the big three, we're looking at center, shape, and spread to describe the data set. So the center is the mean or the median. That's kind of where the middle of the data is, right? And there is a difference. The median is 50% of the data, where the mean is the average of all the data together. So it uses every single data point to include it. But we want to kind of get an idea of where's the middle of all my data. And then the shape, there's different ways of talking about the shape depending on what you're seeing. You have uniform, symmetric. It could have different modes to it, either bimodal or multimodal. It could be skewed to the higher numbers or lower numbers, and I'll show you in a second what I'm talking about. And then also the spread. So we want to somehow get down, like, how wide is my data set? I know where the center is now because you've told me, but how wide or separated out is that data, right? Is everything really close together, or is it such a huge range of data, right? So we can use standard deviation for that. That's calculated using every single data point. So it gives a general, like an average distance away from the mean. So it tells you kind of on average how far each data point is away from the mean. We have the interquartile range, which is your Q1 and your Q3, your first quartile and your third quartile. So this gives you an idea of how spread out your middle 50% of the data is. And then, of course, you have your range, which is your minimum to your maximum, which gives you an idea of the overall range of the whole data set, the whole 100% of it. You can talk about individual quartiles, like, oh, the first quartile is really spread out, while the third quartile is not, blah, blah, blah. So when you do a problem, you definitely need to hit these three: center, shape, and spread. When you do an AP statistics problem, those are the three things they're looking for, and that's what you're going to get graded on, is those three things. Now, of course, they want to know if you have any unusual features going on. Is there a gap or some clustering going on or something like that? But that's usually a little extra. And then if you go back up to these acronyms up here, you can see the C for the center, and then the two S's for shape and spread are in these acronyms. There's a C and two S's. And then a lot of them, they put the U in there for the unusual features. There's the U and that one. And then the extra C on this one and the BS part of it on this one is just talking about writing everything up in context. So this one says be specific. So the BS is the be specific. Make sure you use context when you're writing these three things up. This C stands for context, right? So what I just talked about, center, shape, spread, unusual features, and then use context. That's what these acronyms are for. But really, it's the three: the center, shape, and spread. That's what you're going to be graded on. Those are the things that we're looking for when we grade a problem, and AP grades as well. Okay, so I put up a couple slides. There's pictures I found on the internet, just to give you an idea. So we got uniform distribution, and this is what a box plot might look like for that. This one would be symmetric, right? Let me go back. So the uniform, let me go through the three. So the center would be about 16. And when you have a histogram, you can give a range. Like this is 14 to 18 is the center, right? The center of this one over here would be the same, 14, 18, right? The center of this one, it depends. It's skewed. So it could be the mean and the median will be a little bit different. These two, the mean and the median will be exactly the same because they're symmetric. So on this one, the mean will be closer to the skewed end. So this one's skewed to the left, or what we like to say is skewed to the lower numbers. It's a little more descriptive. It's better to use the lower numbers. So this one's skewed to the lower numbers. It's kind of like someone grabbed the tail of this and pulled it to the left. Okay, so the mean is going to be closer down in here somewhere. I don't know where exactly. We'd have to have the numbers to calculate that, but the median is probably going to be higher, like 20, 24, maybe 22. Somewhere in there is probably where the median is going to be. But the mean, the average, is going to be a little lower than that, like 14 or 15 or somewhere down in here somewhere. Okay, so that's something to keep in mind. So that's center. The shape of this is uniform. Shape of this, symmetric. Shape of this, skewed to the lower numbers. What's the spread of this? Well, this has a spread from 0 to looks like 30. They really should be putting these numbers on the boundaries. So I'm assuming it's kind of like, I don't know, 2, 4, 6, 8, 10, 12, 14. That's kind of what I'm assuming, but they should have done a better job of marking this. But that's what I'm assuming. So this looks like it's going from 2 up to 30 is what it looks like to me. So that would give a range of 28. This one goes from 2 to 30 as well. They all do, right? So they all have the same range. The IQR, this one's going to be, first quartile would be over here like at 10 somewhere, and then maybe over here at 22 somewhere. So it'd have a IQR of about 12. This IQR, since more of the data is in the center, it's going to be a little shorter, right? It's going to be a little more compact. So the IQ on this one would be smaller, maybe like 4 or 5 or 6. Be a short IQR. This one's going to be in between these two somewhere. So maybe quartile 1 here somewhere and quartile 3 here somewhere, maybe. That one's kind of hard to tell when they're skewed like that. Let's look at another picture here. Okay, so this gives you some more diagrams like symmetric. Yes, normal curve, symmetric, skewed to the higher numbers, skewed to the lower numbers. This one's evenly uniform distributed. This is bimodal. You can see you have 2 peaks, so we call that bimodal. Not only is it bimodal, but even though it's bimodal, you can call it symmetric. This one is bimodal as well, but since this peak is higher than this peak, we're not going to call it symmetric. This one's just kind of a more narrow spread to it. So this down here is talking about spread. This has a low spread. This has a higher spread. So the standard deviation of this would be smaller than the standard deviation of this, right? This would have a larger standard deviation. And this one would be similar to the first one in spread, but this outlier will affect some of the spread. Like if you calculate the standard deviation, this outlier will affect the standard deviation, as well as affecting the mean. Like the mean will be pulled that direction because of that outlier data point. In another video, I'm going to stop this video. In the next video that you'll have in this series, I'm going to be doing work on the TI Nspire, and we're going to look at box plots and the 5-number summary and how to get your statistics on the TI Nspire. And then in other video in the same series, we're going to be looking at how to calculate outliers using the IQR method and the standard deviation method, as well as how to use the TI Nspire to get different graphs and histograms, and how to get a density graph and things like that. Okay, so please look for those other videos in this same series.